Okay, let's get started on the advanced deformation section of this course. And we're going to keep it as simple as possible. And actually, I'm just going to add a couple of extra advanced deformers to this character. But obviously, you can take this and apply it elsewhere, depending on the kind of work and character you're working on. So what I'm going to do is we're going to add a few advanced rigs that will enable us to simulate muscle movement and bone movement under the skin. So the idea behind these rigs is to allow us to have better control of how the mesh is deforming, but it's not only going to be based on the movement of the joints that are deforming the mesh, but also on more complex rules that we are going to set up. So what we're going to do as practical examples is we're going to create a fake muscle for our pectorals, the character out here, so that we have more control over how this region of the pectoral muscle moves. And we're going to create also a bone for the scapula, so we can see some movement under the character over here. Now, obviously, this is going to be somewhat limited due to the fact that this mesh was not modeled with any of these movements in mind. So I'm just going to show you how to do it, even though the resulting deformations might not be as realistic as we would like. But if you want to get something like that, you need to have more realism. You just need to have a mesh that is modeled with these deformers in mind. And you're going to understand this better at the end of this section. So when I talk about simulating muscle movement, I'm not really talking about creating an object that will slide underneath the mesh and deform it as it slides and change the shape as the joints rotate. There is no such a thing as a muscle primitive in Modo. So the creation of this course, maybe in the future, we don't know. But we can certainly create some extra deformers that sort of mimic how a muscle moves underneath the skin. And in this case, these deformers are going to be simulating something that is attached to the skin somehow, that the skin is attached to the muscle, actually, the other way around. So I'm going to create one around here that can pull this region of the mesh up and down based on the movement of the clavicle and the arms. All right, that's what we're going to do. And then we're going to do obviously one for the other side. And that's pretty much it. We're going to do for the chest. You could create more of these extra deformers. Like, for example, it would make sense to create one here close to the center of the solar plexus, so that we can squeeze the pectorals when he brings his arm forward. I'm not going to do that directly as part of the course, but once you've done the one we're going to be doing the other one should pose no problem at all. So that being said, let's get started. The first thing we're going to look at is in this video, I'm going to show you how to insert extra deformers into a mesh that has already gone under a bind operation. Because obviously we don't want to have to redo the binding on the character, because we've already have all of our maps, our vertex maps that determine how all these weight maps we already worked on and painted by hand and transferred. We don't want to lose that information. So instead of rebinding the mesh, I'm going to show you how to edit the bind. It's a little bit convoluted. Well, it's not convoluted. It's just a little bit of work, because there are no tools in Modo as of today to insert new influences into a bind system. But it's actually very straightforward to do. So let's begin by creating our deformers, and to do it in context, I'm gonna bring up the deform skeleton. So this is what we have so far to deform our mesh. So we're gonna create a couple more of these, one for each side of the character on the pectoral area. So let's create a locator, and I'm going to move to a front view, and I'm gonna move it up and position it where I need it, which is more or less around here. This is where he's going to have its influence is going to start from the center of this polygon and irradiate outwards. And we're going to actually paint a weight map for it and everything, so you don't have to worry too much about that. Now let's go to a side view, move it forward, and check in perspective if all that makes sense. He's actually protruding from the mesh, so let's move him in kind of like there. I guess this makes sense. Okay, and now I'm going to change its shape. Let's make him into a nice sphere. And we're going to make him smaller. Let's say 10 millimeters. And I'm going to color him. I'm actually not going to color him red because that's the color of our original locators. I'm going to use probably an orange just for me to know that this is not a this is not one of the original bind deformers that I have. Okay, so let's rename him, and let's see what names do we have here. Deformer, side, and the name of the deformer. So we're gonna call this guy deformer right pectoral pec muscle low. In case you had like a center one and a top one, as I said, you can take this as far as you want. Okay, and now I'm going to duplicate it and take the duplicate and move it on X to the mirror position, and we're going to call him left side, and that's it. Now for these guys to be able to be part of the skeleton of the hierarchy that we're using to bind the character, we need to bring them into the hierarchy. Now the thing is, I'm doing this basically in case that at some point the character needs to be separated or detached from the deformers and then rebound later. So the binding process would be able to take these new deformers into account when binding. So before I do that, one of the requirements of the binding process is that everything must be in a hierarchy, and usually the last item in the hierarchy is not weighted in towards the mesh. So for example, in the case of the fingers, we have these guys that are outside of the mesh that do absolutely nothing except fulfilling that requirement. The tool needs to traverse the hierarchy until it reaches the last element, the last child, and then leaves that one alone. So for this guy to get weight, it needs to have one out here that doesn't do anything except allow this guy to have weight. Because otherwise, if this item was not here, this deformer here would get no weight at all, and then we have nothing to deform the tip of the finger with. So with that in mind, I need to give these guys a child too. So I'm gonna select the first one, and actually let's select both and duplicate them and take the duplicates and move them out of the mesh. Okay, so those are going to be the children, and we can actually make them smaller just so that they don't interfere, because they're not going to be of any use at all. And now we're going to take each one of these guys and just give them a terminator suffix. So I know that this terminates the chain right there, and parent them to their corresponding deformer. Let's do the same with this one. And this guy's parented to this one. Okay, so far we're doing well. Now we need to bring these guys into the hierarchy. So based on what I see right here on this view, I would say that these guys need to be a child of this deformer right here. based on their actual position. But I could also say there would be childs of this guy based on its area of influence. So I think I'm going to go with that. I'm going to go with this deformer right here because this one is really influencing the chest area, which is where these guys are going to be working on. So let's take a look where this guy is in the hierarchy. It's spine 05. That's our deformer. So we're going to take our 2 new deformers, and let's move them up and find spine 05 and parent them right there. Now they are children of that deformer. Okay, so let's see if the character moves, and you can see our new deformers are following quite nicely. Our hierarchy. So that's good. Now, they don't do anything yet. They don't deform the mesh. And before I do that, this is not going to be set up in a way where I just parent them to this guy and then we paint the weights and we're done, because that is not going to do anything. That is not going to give us the illusion of a muscle moving down here. That illusion is going to come from these guys moving when the arm moves. This guy needs to go up and down and maybe a little bit to the center and stuff like that, okay? So for that to happen, I need other objects that these guys are going to be dynamically parented to, that are going to be the actual rig of our pectoral area. So let's start creating those. Now that we're done with this skeleton, I'm just going to collapse everything. I'm not going to hide it, just going to collapse it. And we can start the rigging process. So we'll work on one side first, and then we'll move on to the other side. Let's go ahead and create a new group for our character. And let's see. Let's call this new group locator group center advanced deformations. Okay, just for me to separate this from the deformed skeleton. And let's put it right under it so they're close together. Advanced deformations rig. So I know it's the rig only. And let's start creating the elements we need for this. So I'm going to start by creating a locator. And I'm going to set my drop action to match. Let's drag and drop it onto our friend here. Okay. This is going to be the locator that is actually going to move. So let's make it smaller. And let's call this guy locator right pectoral mover low. Okay. There we go. Because this guy is the guy that is going to move. Now he needs to move relative to something else. So we're going to give him a parent. And this parent is going to be a box. Okay, there we go. Now we just parent them together. And we are good. Okay. Now that we have these guys, I can take the parent and I'm going to mirror it to the other side. So I mirror the hierarchy on X and I get my opposite side rig. Well, just the elements at this point. So let's rename these guys. Okay. And now we take these two and move them into our advanced deformations rig group locator. So far so good. Okay. So what we need to do now is to get these guys to do something. So I need to start the rigging process of these locators onto, well, they're going to be relative to the movement of the arm and of course the clavicle. We're going to do that in a separate video. It's going to be the next video because it's a little bit involved. And as I said, since this is an advanced rig, it does require some advanced systems for it to operate. And it's going to take a little bit time to explain. So I want to do that in the next video instead of doing it here and creating a long one. So I think we have the elements we need to work with for this. And we're pretty much done. So let's go to the next video and see how this is going to work. Okay, so let's talk a little bit about how this rig is going to work. What are the requirements for it to work, what it needs to do, and also why we're doing this basically in the first place, because it makes no sense to spend time working on something that has no purpose or that the purpose is not clear. So let's talk about why we're doing this. The reason we're doing this is I've been observing how this character deforms up to the point that we are right now, which is we basically took our weight maps and our weight values as far as we could with the tools that we have out of the box. And I've seen that the deformations are not yet what I want. Okay, in this area in particular, I want to simulate a little bit of muscle mass over here because this character, as you can see from its shape and its topology, he's a beefy character. He's a strong character, and we want to be able to see some muscle movement in here that gives this illusion of the character having some weight to it and strength. And as you can see, as the arm is moving, we really don't see much movement in here. Why? Well, because there is no weight coming from these deformities here influencing this area. And I don't want to add them like that, because then it means that whenever these guys did something, they rotated or moved, they would be moving vertices over here. And that might actually create more problems than the one I'm trying to solve. So what I want to do is I want to move these vertices around when these guys move, but in a very specific way. So for example, let's say that I say, well, I would like that when the character raises his arm like this, this part of the muscle is pulled up and left a little bit to follow that movement, right? And you can pretty much see this by just taking your shirt off in front of a mirror, or asking a friend that looks like this guy to do it for you, and asking him to move his arms up, down, back and forth. So we would see that the pectoral muscle, because it's attached over here to the shoulder, it's following those movements. And that's what I want to simulate right here. So we're trying to simulate movement based on the rotations of something else. Okay? That's what we're doing. Why are we doing it? Well, again, because I want to see some deformations here. This looks like something I would need to fix later on. Based on the movement of the arm. And that's pretty much it. I want to enhance those movements. Okay. So that now that we have those things cleared up, how is this going to work? Well, let's bring up the right arm rig. Oh, that's the leg. There you go. So here's our arm, okay? You can see the arm moving around. So what I would like to do is say, okay, this muscle's movement is going to be determined by this joint right here, okay? Wherever this guy rotates, I want to know about it. And then I want to be able to take those rotations and say, okay, if the arm is moving up, well, rotating up, I want this guy to perform a certain movement. But if the arm is rotating down, I want the movement to be different. If it's going to be rotating backwards, like that, then I want this to move differently. And if it's rotating forward, then it also needs to move in a different direction. So I cannot just take this rig and parent it to this joint and say, okay, I'm done, because that's definitely not going to work. We are basically creating a rig that needs to have different behaviors based on the angle and direction of this joint. Okay? So that sounds a little bit complicated. So we need to think a little bit about what that actually means. It means that I need to track the rotations of this joint in space. I need to know where those rotations are going, and I need to know their values. And now, based on those values, I need to feed that as movement onto this guy. But those rotations could be going in different directions. They could be, the joint could be rotating on its z-axis, or the x-axis, or the y-axis. So I need to know about that too. Now, that's a lot of stuff to try to get from a single item, but I need those separate because the movement of the muscle is going to be different based on those axes and on the values of those rotations, because it's not going to be the same for the character to rotate its arm, say, on the y-axis in the positive direction than in the negative direction. The movement of this guy is going to be different. So if you're still following me, that means that we need sort of like a specialized mechanism that will allow me to pull not only the rotations of an item like this, but also the direction in which they're going. And then based on that information, I can decide what to do with another item in the scene. Okay? So how are we going to do this? This is where knowing math comes in very handy. I suggest that as you progress in your rigging aspirations, if you decide that rigging is what you want to do, you really start to take out those old books from high school around algebra and trigonometry and stuff like that, and undust them and reactivate those brain cells that hold that information for you, and get that knowledge back up to speed, because you are going to need it. So in this case, we're going to use some math to solve this problem. Now, when you're facing a situation like this, that is going to be a little bit of a trial and error and trying stuff out, I really suggest you build a prototype in a totally separate scene. And you have to make your prototype as simple as possible. It has to have as few elements as you can, so that you don't get confused with all the moving parts and the things that you're throwing in there. And it needs to be super simple so you can read exactly what's going on. That's what I've done here in a separate file. I've created this little prototype, okay, that allows me to try out ideas around how I'm going to get this to work. Now, obviously, I've already solved this problem for you, but I'm going to explain to you what I did so that you know why I built this. So I have these two locators, one called rotator, one called arrow. And this simulates my arm of the character. Okay, this is the shoulder joint, and let's say this is the upper arm, okay, and this is my elbow, and there would be here another part of the arm and the hand. I don't need to do those. As I said, we have to keep it as simple as possible. So this guy is the one doing all the rotations, okay? He's doing some stuff like this. I just wanted to test what values I would be getting by rotating to different parts of the character. Now, as part of the rig, I'm using these other 4 locators, and these are targets that I'm using to mark different parts of my character. So this, for example, if I were to be looking at my character from the front, and the head is right here and the torso is right here, and this is the right side of the character, his right arm, this would be the front of the character, the top, the back, and the bottom. Okay? To keep things simple, again, I've labeled them as north, south, east, west, and that is labeled as I see them from this point of view. So this is north, south, east, and west. Okay, so those are going to be my target directions. And what I did is I built a rig that allows me to know which way this arrow is going. I did a small animation, moving it to north, back to neutral, then east, then south, then west, and then randomly some other places to see what I am going to be getting out of this rig. Okay? And the way this rig works is it uses a vector operation called the dot product. I don't want to turn this into a math course because some people might not be as interested in that as just getting characters to move, but unfortunately math is part of the process and it's very important when you start to rig some more advanced stuff. So again, I'm not going to really explain what the dot product operation is. If you want to know, in very simple terms, it's basically adding up the product of the components of each vector. In this case, we need two vectors. You can look it up in the web. I'm sure you can. If you just Google dot product, you'll see what it is. But I'm going to show you how I'm using it. So I created this little rig. And basically what I'm doing is I'm taking each target. In this case, let's start, for example, with north. We have this item right here. And I took its world position and I converted it into a vector using a matrix vector node. Okay, so this allows me to take the world position of this guy. Right now I'm using that. I don't know if that's what I'm actually going to use, but for now, let's say that is that. And I'm creating a vector out of it, which basically allows me to just have X, Y, and Z components for the position in space of this item. Then I am taking that and feeding it as the first vector for the dot product operation. Okay, and my second vector is going to be my arrow. Okay, right here, this one that is actually moving. That's what I'm going to be tracking. Why am I ignoring this guy? Well, it's because this guy is rotating. And if I wanted to actually start to deal with rotations, that would be a lot more of a hassle because rotation math is actually more complex. And the best way to do that requires some nodes that unfortunately don't exist yet in Modo. So I'm not going to try to go into that and just complicate my life. I'm going to use vectors, and that's far easy to do. But vectors are basically positions in space. So I needed something that would change its position based on the rotations of the joint that I'm trying to track. And the easiest way to do that is just to take another object, make it the child of the one that is rotating, and distance it a little bit from it. Okay? And that way I can track positions in space. So that's what I'm doing right here. And to keep things simple, remember, simple, I've made all the positions constant among all the items. All these items are 2 meters away from the origin, okay, including my arrow. It's 2 meters away. So that way I know exactly what I'm dealing with. Normally it's more useful to deal just with 1 meter, so you have ones all over the place. But I just want to see what this does at this point, okay? Now, what is the dot product operation doing? Well, it's giving me the dot product between this vector and this vector in this case. So let's take a look at what that does. I've gone and already created a little table here of channels that I'm reading directly from these nodes, the dot product nodes, and throwing them up here so I can see the values change as the animation goes. So let's keep an eye on the dot product north components, the first 3 right here. So I can see that as I start approaching the north point, I can see that the X component is increasing its value, okay, until it reaches the total value of 4, which is actually makes sense because the vector length from the center of the universe, or the origin of this rig, up to the north marker is 2 meters, and the vector length from the center again to the arrow is another 2 meters. So I'm getting a consistent value right there. Okay, so far so good. Let's see what the animation does next. It starts to go back to the neutral point, and I can see this diminishing up to when it reaches 0 again. Now I'm going to go east, so you can see the X component of the east vector, of the east dot product, it's starting to increase. Okay, but now I changed here the plan. Instead of animating it going back to the origin and then down and back and left and back, because that's just going to give me the same results, I decided to rotate directly from this position to the south position. So let's see what that does. As you can see, I'm starting to get something really funny here. I'm starting to see more values popping up. So we have the x component of the north dot product going negative. Then I have the east one diminishing from 4 down to 0. I have the south one increasing from 0. I'm sure it's going to go up to 4. And I have the west one also in the negative value. Okay, so when I reach the south position, I can see that my south dot product operation has a value of 4. Now, interestingly, the north one has -4. It's not 0 anymore. It's gone negative. Okay, that's going to be very useful, and I'm going to show you why later. So I'm going to continue. You can see the same values working their way up and down until we reach like total force or close to force. And then here in the random section, I get to see some rather interesting values. Now this is going to be important because actually the movement of my arm is going to be more like this. It's going to be rotating around this area, never really reaching the markers. Because as you can see, if we see this from the side view, in the rest pose of my rig, there is a 90-degree angle between my tracking arrow and the markers I'm trying to track to. So this makes calculations a lot easier, but it's for sure I'm never going to be bending my arm this far up without moving the clavicle or down. So now what does this all mean, and how does it get applied to our rig? I'm gonna go back to our movement. Let's say this one, okay? Let's track rotations relative to the south position. Now, if I see this, let's say we have a value of 3.9 on the south x component of the south dot product, okay? Now, if I see this, I will see a very similar value, okay? As you can see, 3.95. Here, 3.94, 95. It just basically changes a little bit, but it's almost the same. And that is a problem because I know now that when I reach the south position, this value is going to be 4, which is great. So I can say, I can use this value to drive part of the animation of my other locator, the muzzle, right? But the problem is, I can't really tell in which direction that movement is going. Because if I'm coming from the front of the character, it gives me the same values that if I'm coming from the back or going towards the back. So that doesn't really help me much. Because, yeah, I could use that to get a pose for this position, but then if the pose needs to be different from the front side than from the back, I'm not going to get that because I have only one value to work with. Well, that's where other values come into play. And in this case, I can use the east and west values, okay? Why? Because when I'm in the front of the character, I can see that my east value is positive, okay? And the west one is negative. So this allows me to know I'm coming from the front of the character. And this one, it's the opposite. It's negative on the east and it's positive on the west. So now I have the means to know on which direction I'm rotating or the joint is rotating, okay? I can just say, okay, this is going to be, let's say, the weight of the pose, how much of the pose I'm going to achieve, but these two values are going to help me know which pose I'm looking for. If it's the pose when the arm is on the front of the character or the pose when the arm is in the back of the character. So that's how this rig basically works. Okay, those are the principles. So now I can know how close I am to a given target position to trigger a given pose on my muscle. And I also know in which direction I am rotating. So I can say, okay, the arm is rotating forward towards this guy, then I need to pose my muscle this way. If I'm rotating backwards, then it needs to go in a totally different pose. Okay? I hope this was clear. I'm trying to make it as clear as possible. Don't worry about this. This is the prototype. We're not going to use this in the rig. All I wanted to do is to show what I'm going to be using, which is the dot product operation, and how it works and why I'm using it in this case. Okay, the rig is definitely going to change once we bring it into our main rig, and that's fine. That's what prototypes are for. You just want to basically find a way of getting things to work at the conceptual level, even if you're going to change it later on. So that's done. We've found our solution for this particular problem, and now we can actually start building it into the rig of the character. Okay, so let's go back to that in the next video.